All right, so chapter 4 is the applications of derivatives. So now we are applying the rules of derivatives that we learned from chapter 3. The first section is about extreme values of functions, more specifically extreme values on graphs. We've done this before with maximum and minimums and absolute maximums and absolute minimums, but now we're going to learn how to use the derivatives to figure these things out. So the absolute max and absolute min. Absolute max is global. That means you look at the whole entire function from beginning to end within a domain sometimes, or the whole entire function from negative infinity to infinity. Same thing with the absolute min. It's the smallest y value on a particular interval, and the absolute max is the largest y value on a particular interval. So let's consider this graph of y equals x squared and its various extrema on different domains. So if we looked at the domain from negative infinity to infinity, is there an absolute max and is there an absolute min? And if there is, where are they? Now absolute max, this graph, does it ever really stop? No. So there is no absolute max. Now absolute min, obviously globally looking at the whole entire function from negative infinity to infinity, the absolute minimum is going to be where x equals 0. But remember, absolute maxes and mins are the y values. So our absolute min is going to be at y equals 0. Now here we're closing off the interval, and 0 and 2 is included. So basically we're looking at the graph from here to here. Okay? And so looking at this graph from this area to this area, ignoring everything else, the absolute max is, because 2 is included, it is going to be at, sorry, this should be 2, 4. It is going to be at x equals 2, but remember we give it as the y value, so it's at y equals 4. And then the absolute min, because it's included, it's going to be at y equals 0. And here's what I mean. So the next domain is going to be from 0 to 2, but 0 is not included. So our absolute max here is included. Okay, it's at 2. So our absolute max is at y equals 4. But we have no absolute min, because we can't really figure out how close this is getting to y equals 0 without actually touching y equals 0. And so here, if they're both open intervals, then there are no extremas. Okay? So which brings us to the next part. The extreme value theorem, which states if f is a continuous on a closed interval, so it has to be continuous on a closed interval, a to b, then the function f has both a maximum and a minimum value on that interval. So to have extremas, they must be closed intervals. So that's basically what the extreme value theorem is saying. So to have extremas, you must have a closed interval. Alright, moving on. So possibilities for continuous functions max and min on a closed interval, a to b. So here's my closed interval from a to b. We're going to look at the max and min at interior points. Now, these 2 points right here are endpoints, aka exterior points. They are happening at A and at B. So the interior points, you'll notice that this is going to be our max and this is going to be our min. And what do you notice is happening at the max and min? What is the slope? It's 0. And how do we find the slope? By finding the derivative. So the absolute max and min, the interior I should say, absolute max and min, occur when the derivative is 0 and or undefined, and we'll come back to this one in just a second. Okay? So you can either have max or min points inside the interval, locally, or you can have max and min points at endpoints. Now it doesn't mean that this point right here is not a max or a min. This could be our absolute max if it went up higher, and this could be our absolute min if it was lower. Alright, now the way the notes are set up is kind of a little bit odd. We are not going to do the examples yet until we review this next definition, which is critical points to find extremas. So how do we find extremas? We have to find the critical point. And basically, what is the definition of a critical point? It's a point in the interior of the domain, so interior of the closed interval of a function f, at which the derivative of that function is 0 or the derivative does not exist, which means it's undefined. And those are critical points of the function f. Extreme values occur only at critical points and endpoints. So when we are trying to find the extreme values, the absolute maxes and mins, we are going to have to figure out where the critical points are and where the endpoints are. Now the endpoints are given by the interval, but the critical points we have to do math, aka find the derivative, set it equal to 0, and find the derivative and figure out where it's undefined. So consider this following graph. So this is just a graph. I tried to draw it as good as possible, and it's on an interval between x1 and x8. So looking at this graph, in between this interval, you can see that we do have an absolute min, and we do have an absolute max. So our absolute max is at a corner, which is a critical point, right? It's on the inside. It's not within the interval. We do have a local max. Here the derivative is 0. And we do have a local min, where here the derivative is 0. Now our exterior point is neither a max or a min, and that's okay. So x8 is not a max or a min. So what I want you guys to notice is that all the interior maxes and mins, the derivative is either 0 or undefined. And the endpoints don't have to have an extrema. Alright, now we can actually do the examples that are left over. So here's our first example. So I don't know why this was put in this order, but it's fine. Alright, so our first example, it says find the absolute max and min values of this function. Now there are two ways to do this. We can do it analytically, or graphically. But if you're doing a quiz without a calculator, then you can't really do it graphically. Graphically would be very easy. You would graph this function in the calculator and then find the max and min within this domain. But I'm going to show you how to do it analytically. So there are two steps. Step 1 is we have to find, if any, I should say, because there won't always be some, the critical points. Because that's going to help us figure out if the absolute max or min is inside of this domain or not. So to do that, we have to find the derivative of the function. And the derivative of this function is going to be negative 2x. So remember, the critical points, there are two places. It's either when the derivative is 0, so that's what I'm going to do. I'm going to set my derivative equal to 0 and I'm going to solve it. And I end up with x equals 0. So at x equals 0 is a critical point. It's a point inside of this domain, and you notice that it is inside that domain that represents a possible max or min value. Now, can this function ever be undefined? No. So this is our only critical point. And then step 2 is we are going to find the y values of the critical points and endpoints for f of x, for the original function. So basically, when f is negative 3, what is y? So you plug that in. Negative 3 squared is 9. 4 minus 9 is negative 5. Next up, I'm going to plug in 0 just to stay in order. So negative 3 is the smallest, and then f of 0. So 4 minus 0 is 4. And then the last one is f of 1. So I have 4 minus 1 is 3. So remember our definitions, which say the absolute max is the highest y value within the interval, and the absolute min is the lowest y value within the interval. So our lowest is right here, and what this means is that this is my absolute minimum, and my highest, you notice, is at my critical point, and this is my absolute max. Okay, and that's basically all we need to do, and then you can confirm it by graphing. So by graphing this function and focusing on this interval. Now at f of 1, it starts going back down. So basically you can picture this. So at negative 3, 1, 2, 3, it's about negative 5. At 0, it goes all the way up to 4. And then at 1, it comes back down. So in between this interval, this graph does one of these. So you can tell that this is the absolute max, min, and this is the absolute max. Alright, next example. So we're always going to follow these two steps. We're going to find, if any, the critical points. And the way you do that is you find the derivative and you try to see where is the slope of this guy 0, or where is the slope undefined. So what I want to do, and of course these are the endpoints, so we'll do that in step 2. So step 1, I'm going to find f prime of x, and when you find the derivative of this, you bring down the 2/3 times negative 3x, and then 2/3 minus 1. And what happens to these 3's? They cancel out, so you're left with negative 2x to the negative 1/3. And if I rewrite this, it's negative 2 over x to the 1/3, and that's the same thing as saying negative 2 over the square root of the cube root, of x. So now remember, because x is in here, usually we would never want to have a negative in there, but this is the cube root of x, so it doesn't matter because you can have negatives when you're taking the cube roots. So now the question is, where is the derivative 0. And here, the derivative will never be 0, because if it is 0, then it's going to be undefined. So the derivative is undefined at x equals 0 because we have a radical and it's in the denominator, so we can't have a 0 in the denominator. So this is a critical point. But if you try to solve this and set it equal to 0, you really can't. So the graph will never be 0 because it's undefined. But that is a critical point. So now step 2, our endpoints are f of -1 and f of 1, and then my critical point is f of 0. And I'm just going to plug those in. So -1 raised to the 2/3 times -3. So that ends up being 1. So because -1 raised to the 2/3 is going to be 1, because remember, this is -3 times -1 squared, so the cube root of -1 squared, and -1 squared is 1, cube root of 1 is 1, times -3 is -3. At 0, it's going to be 0, and at 1, when you plug in 1 back to the original, we're going to have -3 again. So what does this tell us? Now, our lowest point is at -3, but we see it twice. So what this is saying right now is in between this interval, if I graph this really quick, at -1, we are at -3. And at 1, we are at -3, and at 0, we are 0. So this interval is kind of doing one of these. So let's graph this. And see why. So I'm going to go to my graph, tab, so I'm going to enter -3, and then x raised to 2/3. We're going to graph this, and what do you notice? See, the way I graphed this was wrong because I completely forgot that when x is 0, this is undefined. So what does that mean is that we actually have a cusp over here. Okay? So, and that makes sense. When it's 0, it's undefined. There's no slope. And then these are my endpoints, and they're both equal the same. So, what this means is that this right here is going to be my absolute min. And remember, we only care about the y value when we're talking about an absolute min. So my absolute min is at -3. And my absolute max is at the highest. It's at 0. Alright, I do want to leave the last one for tomorrow. I mean, feel free to start it if you want to, but it just gets a little bit complicated if you don't remember your unit circle. Alright, enjoy.